Hello everybody, this is the physics exam review worksheet for grade 8 semester 4 for the final exams at the International School of Innovation. Let's start with some notes you have to study. You have to know that if a vibratory phenomena is the succession of oscillation about an equilibrium position, these notes are about the characteristics of waves. A wave is transversal if it produces deformation perpendicular to the direction of its propagation. So transversal, it's perpendicular. This wave is a longitudinal if it produces deformation which are parallel to the direction. So transversal, it's always related to perpendicular, and longitudinal is always related to parallel. A propagation of wave occurs without the transport of matter. So here we know that transversal is related to perpendicular, longitudinal is parallel, and wave doesn't transport matter. A phenomenon is said to be periodic if it repeats itself identically in regular intervals of time. The period T, what is the period? The period is the smallest interval of time at the end of which a phenomenon reproduces itself identically. Its unit is second of symbol S. The frequency 1/T is the number of periods per unit of time. It's expressed in hertz. So frequency it's 1/T is expressed in hertz, while the period T is expressed in seconds. So this is the difference between the period and the frequency. F it's equal to 1/T, okay, and T is equal to 1/F. Moving to the sound waves, all of you have to know that sound, they have a vibratory origin. The audible frequencies, they range from 20 Hz to 20,000 Hz, meaning that 20,000, 20 kilohertz. This range below this is called an infra, so below this range is called infra, and above this is called the ultrasound. Sound transports energy. In air at room temperature, the sound travels at the speed of 340 meters per second. The sound pitch allows us to determine whether the sound is strong or weak. Sound undergoes a reflection when it encounters an obstacle. The sound volume allows us to determine whether the sound is loud or low. So sound volume. During the reflection, the angle of incidence, you have to know that angle of incidence is equal to the angle of refraction. So these angles, they are equal. The echo, sonar, ultrasound, all of them, they are application of ultrasonic and reflection. Electromagnetic wave is due to an electric disturbance. Electromagnetic wave doesn't need a medium to propagate. Light is an electromagnetic wave which propagates in vacuum. A transparent medium is a medium which lets light to pass through. You have to know that opaque medium is a medium that doesn't allow the light to pass through. Translucent allows some of the light to pass through. In vacuum, the speed of light, this one you have to study it. The speed of light in vacuum, or the speed of light in vacuum, is about 3 times 10 to the power 8 meter per second. This one you have to study. Electromagnetic wave is characterized by its frequency, period, and the wavelength lambda, which are the symbol this one, lambda. So lambda is equal to C times T. Maybe this C is going to be V in some exercises. C times T times the period, or C times the period is going to be to 1/F, so it's equal to C/F. So this one also you have to study this equation or this formula. Lambda equals C times T equals C/F. In vacuum or in air, the wavelength of the visible light ranges between 400 mm and 800. Each wavelength corresponds to a particular light color. A light source which emits light of only wavelength is called monochromatic, while the one which emits more than one wavelength is called polychromatic. This is the case of the white light. So have to know monochromatic, definition of the monochromatic, also the definition of the polychromatic. The dispersion of light is the composition into its different color which compose its continuous spectrum. It's in continuous manner. Now let's start with the exam review worksheet. Let's start with question number 1. A wave is characterized by its wavelength lambda, frequency f, and period t. You have to know that the unit of the wavelength lambda is meter, the unit of the frequency is hertz, hz, and the period unit is second, symbol small s. So what does each of the above terms represent? What does wavelength represent? What does the frequency represent? And what does the term period represent? Here we have three waves, A, B, and C. You have to complete the table showing the calculation. Let's start first. What is the wavelength? Wavelength is known to be the distance that is covered by the wave in one period. This is the wavelength. The frequency of the wave is the number of oscillation performed during 1 second, and the period t of the wave is the time needed to perform one complete vibration or one complete oscillation. So to start with, this is the wavelength. The wavelength is defined by the distance covered by the wave during one period. The frequency is the number of oscillation in 1 second. The period t of the wave is the time needed to perform one complete oscillation. Go back to the table. Here we have lambda, we have v, which is c speed, we have t the period, and f the frequency. First calculate period. Period is 4 seconds. Frequency is equal to 1 over t, it's equal to 1 over 4, so it's equal to 0.25 hertz. Moving to lambda. Lambda is equal to v times t, it's equal to 5 meter per second times 4, so lambda is equal to 20 meters. Let's continue to the second. We have only lambda and we have frequency. F t is equal to 1 over f, it's equal to 1 over 20, so it's equal to 0.05 seconds. Here we have lambda, we have t. Lambda is equal to v or c times t, so it's equal lambda over this is going to be 160 meter per second. How? You have to know that lambda equal v times t, so v it's equal to lambda over t, it's equal to a divided by 0.05, then it's going to be 160 meter per second. Move to the third wave. T is 0.125 seconds, so f it's equal to 1 over t, it's equal to 1 over 0.125 second, so it's going to be 8 hertz. Now we will calculate v lambda, it's equal to v times t, so v it's equal to lambda over t, it's equal to 0.2 over t, it's 0.125, so it's going to be 1.6 meter per second. Moving to question number 2. Question number 2 is talking about the sonar. So sonar emits a sound signal of frequency 50,000 hertz toward the bottom of the sea. This signal is reflected on the body of the submarine after a delay of 0.26. So this comes down and it go back with a delay of 0.26. So here, given the speed of the water of sound in water is 1,500 meter per second. It said define the term echo. Echo is the phenomena of reflection of the sound upon hitting an obstacle. It's mainly defined in the echo. Is the signal transmitted audible by a human ear or not? Justify your answer. This is 50,000. In order to be audible, it should be between 20 hertz. Frequency should be between 20 hertz and 20,000 hertz. So this is 20 and 20,000. This one is 50,000, above 20,000. 50,000, so it's not audible by the human ear. So echo is the phenomenon of the reflection of the sound upon hitting an obstacle. The frequency is 50,000 as we said, which is not between 20 and 20,000 hertz, so it's not audible. Part 3, determine the depth. Here we have V. V is equal to D over T. We have time. Okay, we have the speed, we can calculate the distance. But here you need depth of the submarine, so you have to divide by 2. So V equal D over T, so D equal V times T, 1500 times 0.26, T equal to 390 meter. So the depth of the submarine is D over 2, 390, it's 195 meter. Calculate the period, period is equal to 1 over F, it's equal to 0.00002 seconds. Let's move now to question number 3. It's about a sodium lamp. An electromagnetic wave emitted by a sodium lamp has a period of 0.14 times 10 to the power minus 14 second. Calculate the frequency. All of you know that frequency is equal to 1 over t. So 1 over this answer is going to be the frequency. Is the wave visible or not? We know from the calculation, since it's gone 7.14 times 10 to the power 14 hertz, so it's between 3.75 times 10 to the power 14 and 7.10 to the power 14 hertz. So since this one is between, so it's the one is visible, so this wave is visible since the frequency lies between 3.75 times 10 to the power 14 and 7.5 times 10 to the power 14. Does this frequency change when it passes the glass? No, it doesn't change since the frequency is independent. It doesn't depend on the medium. 4, we said, does the wavelength vary? Wavelength, sure, since the speed will vary upon passing from one medium to another. So immediately the lambda will change since it's dependent on the speed. Moving to question number 4. The wavelength of an electromagnetic wave is the distance covered by the wave during one period t of its source. Speed of light in air or vacuum is 3 times 10 to the power 8 meter per second. 1. Give the relation between lambda, f, and the speed of propagation of wave in a given medium. So lambda is equal to v times t, and you know that t is equal to 1 over f. So lambda simply would be v over f or c over f, the same. Determine the wavelength of electromagnetic wave of the limits of the visible spectrum. Here we have the limit 3.75 times 10 to the power 14 and 7.5 times 10 to the power 14. These are the limits. So lambda equal c over f. Here we have lambda. When I calculate the lambda of each one, so you have to calculate each one. Lambda equals c over f, so the lambda equal c over f is c equal to first one, it's called lambda 1, and c over the second frequency is called lambda 2. Let's say, does the wavelength increase or decrease? Let's see. So lambda is equal to v times t, and all of you know that t is equal to 1 over f, so it's v times 1 over f, so it's v over f, the same as c over f. Lambda 1 is equal to c over f1, it's equal to 3 times 10 to the power 8 meter per second, which is c over 3.75, 0.8 times 10 to the power minus 6 meter. Lambda 2 the same, v over f2, 3 times 10 to the power 8 meter per second, divided by the second one, which is 7.5 times 10 to the power 14, going to be 0.4 times 10 to the power minus 6. Does the wavelength increase or decreasing upon moving from one medium to another? The wavelength decreases since the speed decreases. The last question, question number 5. Question number 5 is an easy question. They said seismic waves occur from action within the Earth's core, including breaking and splitting rocks, volcanic eruptions, and explosions. Seismic waves occur on land and in the ocean. The speed of propagation of the seismic wave is about 4 km per second. An earthquake took place in Turkey at 15:38:00. This means 3 48. The seismograph in Beirut recorded this earthquake at 15:50:05. How far is the center of the earthquake from Beirut? So first you have to calculate the difference between the time. T equal, you have to subtract this one from this one. So it's going to be 2 minutes 5 seconds. 2 minutes 5 seconds to be in second, 2 times 60, 2 minutes times 60 going to be 120. 120 plus 5 seconds, so it's going to be 125 seconds. All of you know that V is equal to D over T. So when I calculate the distance, so D equal to V times T. Distance 4 kilometer per second times time in second, let's say it's 125 time in second, so it's going to be 500 kilometer times 10 to the power 3, 500,000 meter. So as we said, this one we have to subtract this time from the other, is going to be 2 minutes 5 seconds. Minute to second times 60, so it's 2 times 60 plus 5 equal 125 seconds. Maybe in your exam I'm going to give you have to calculate in milliseconds, so you have to know that 1 second is equal to 1000 milliseconds. Okay, you have to know this. Pay attention to this note. 1 second is equal to 1000 milliseconds. D equal V times T, so 4 kilometer per second times 125 second is equal to 500 kilometer. So it's about 500 kilometer. You can multiply it by 1000, for example, it's going to be 500,000 meter. So pay attention to these notes, study well. You have to pay attention to the rules, you have to pay attention to the units, seconds for the period, hertz for the frequency, meter for the wavelength. You have to know how to calculate, how to convert, and you have to be careful for some definition you are going to be asked in your exam. So study well, guys. The exam is not hard. Study well, do your best. Bye bye.